Welcome to Learning Chemistry with Faye. In this video, we will learn how to prepare and conduct an acid-base titration experiment. So we'll also go over all the calculations that's related. Let's first look at the setups. Here is an overall sketch of what the titration setups should look like. You should have some kind of a holder, a burette, and a flask. Remember, the titration experiment should be conducted in a flask and not a beaker. Also, when you're making your solutions, acid or base solution, remember to always add the acids and bases into water, not the other way around. Here are some pictures of the actual experiment. When we titrate, we're adding the titrate to the solution. So we're either adding the acid into a base solution or we're adding a base into an acid solution to titrate the solution into a final neutral salt and water solution, right? But what does titration mean? It means you have the same amount of the acid and base in your solution to create the exact equilibrium of your acid and base to create a salt and water solution. So this equilibrium point is called a critical point. But how do we know when the titration has reached the critical point? So that means you have the same quantity of the acids and the bases to create the perfect neutral solution. What we do is we usually add an indicator, which will turn color only under acidic or basic conditions. In our experiment, you will add base into an acid solution. Therefore, the indicator will only turn color, in our case it's a pink color, under basic conditions. And most of the time, the rest of the time, it will remain colorless whenever it's under acidic or neutral condition. This means once the solution turned pink, you have more base than acid in your solution. So what you're looking for when you are titrating is to have a solution turn a very clear light pink, which indicate you had fully titrated all your acid with your base and just past the critical point and have a slightly basic solution. And it's very important to be patient. Otherwise, a lot of times you will make your solution turning a dark pink. Once it turns a dark pink, that means you have a over basic solution, right? So therefore, we also need to know, since we need to calculate and record the quantities of the basic solution, in our case is a sodium hydroxide solution, that we used to titrate our acid, if your solution turns into a dark pink, that means that there may need to be the trial might need to be repeated. And here, let's move on to see what are the calculations related. So first, we need to know how to find out the volume of the stock solutions to make for the solutions that we needed to perform a titration experiment. In our case, we have an unknown solution for our acid that's waiting for us to figure out the concentration of our acid solution. And we need to make a base solution from a concentrated 6 molar stockroom solution to make a diluted version of it. In our experiment, we need about 400 milliliters of a 0.2 molar of sodium hydroxide solution. So how do we calculate that? Since we are dealing with a dilution, the equation that we want to use is concentration 1, so it's M1V1 equals to M2V2. So the M1V1 is the concentration of your more concentrated solution multiplied by the volume that you needed equals to the diluted concentration equals to multiplied by the volume of the diluted solution, right? In our case, what we needed to do is we need to use M1 V1 equals to M2 multiplied by V2. So in our case, we need to make 400 mils of a 0.2 molar solution. So the 400 mils goes to the volume, and then the 0.2 molar goes to the concentration of our second solution. But we also know that we have 6 molar of our stockroom solution, and all we need to do is plug in the numbers to find out the volume that we need for the stockroom solution that we needed to make our base solution. Okay, so once we have done that, we are also going to titrate to figure out the exact concentration of our base solution. That will be your part 1. And then we will figure out how to use the base solution with our written balanced chemical equation of what had happened of our acid and base equations. So make sure you also brush on your balancing and acid and base chemical equation skills. You need a balanced chemical equations for your acid and base reaction, and then to figure out how much of the acid, what's the concentration of our acid solution. So let's go over an example. So here is the example. A 15 milliliter sample of sulfuric acid is titrated using 0.2037 molar sodium hydroxide solution. It takes a 31.86 milliliters of the sodium hydroxide to reach the equilibrium point. What is the molarity of the sulfuric acid? So in this case, just wanted to make a quick note that your 31.86 milliliter is actually the titration volume that you used. Basically, in this case, in your experiment, this is the volume that you have performed to figure it out. To use this kind of volume of your sodium hydroxide solution to titrate the sulfuric acid solution. Okay, so now you have the concentration of your sodium hydroxide solution. You have the volume that you used to titrate the molarity, to titrate your sulfuric acid. So you wanted to figure out what is the molarity, what is the concentration, right, of your sulfuric acid. So the equilibrium point occurred when enough base has been added to completely react with the acid. So that means this is when your solution should turn a very hint of a pink, right? And remember, whenever you're conducting the experiment, you want to swirl your flask around to make sure all acids are uniformly mixed into your acid solution. So make sure you want your base solution as soon as your base is dropped into your acid solution, sometimes you will create a dark pink, but it will quickly disappear. That's caused by that particular drop is concentrated at one spot of your acid solution. So you don't want it to just leave it there. You want it to swirl it around, make sure all your solution is homogenized, and then you can move on. Once the entire solution stays a light, clear pink color, that means you had just hintly, barely past that critical point, and you have completed your titration. And then you will be able to find, in this case, the titration quantity, titration volume, which is 31.86 milliliters. Okay, so first what we need to do is we need to state the product and balance the reaction. So in our case, we already know between the acid and the base, you will always know a particular product for your acid and base reaction. That is water. And in addition, you have to create some kind of a salt, right? So in this case, it's sodium sulfate. But remember, since your sulfuric acid has 2 moles of hydrogen, that means you are able to use sulfuric acid. Each mole of sulfuric acid will give up 2 moles of hydrogen to titrate sodium hydroxide. Okay, so in here, we need to find out how many moles of sodium hydroxide were used to neutralize the acid. We also need to find out how many moles of sulfuric acid were neutralized by sodium hydroxide. And then we'll further find out the molarity of sulfuric acid solution. So let's go ahead and first balance the chemical equation, which is sulfuric acid plus 2 moles of sodium hydroxide to give us sodium sulfate plus 2 moles of water. So without the balanced chemical equation, you will not be able to calculate the molarity correctly for either the sulfuric acid or the sodium hydroxide in your solution. So make sure you get this equation, chemical equation, correct for your experiment first. Okay, so how many moles of sodium hydroxide were used to neutralize the sulfuric acid? Let's always start with the given. In this case, is your volume. So remember, is V final minus V initial for your titration volume that you read it from the burette. Okay, so you have a volume of 31.86 milliliter of sodium hydroxide. And then what you need to do is you need to convert this into the moles, right? But how do we do that? Remember, concentration has the units of moles over liters. That means we need to first convert this volume into liters. Once we converted that, we can go ahead and use the concentration, which is 0.2037. Remember, we can write the concentration, the molarity unit directly into moles over liters. And then we can further cancel out the units of the liters and get 0.006490 moles of sodium hydroxide. Also remember to keep your sig figs. In this case, remember the 1000 milliliter here is the standard conversion. It does not participate in your sig figs. So if you need 4 sig figs, remember here, you will need to have 6490. All the digits in front is a placeholder. You want to make sure to have 4 digits of sig figs for your answer. Okay, so once we actually calculate the moles of sodium hydroxide that we used to titrate our sulfuric acid solution, we can go ahead and look how many moles, we can go ahead and calculate how many moles of sulfuric acid that we used, right? So then we start with what we just calculated, which is the moles of sodium hydroxide, and then we multiply by the conversion from our chemical equation, right? So every 2 moles of sodium hydroxide, we would only be able to titrate 1 mole of sulfuric acid, right? So that means we will be able to cancel out the moles of sodium hydroxide and determine the moles of sulfuric acid. So after we have determined the moles of sulfuric acid, we're able to calculate calculate the concentration of our sulfuric acid. Remember, you have a 15 milliliter sample of sulfuric acid is what you started with. So that means you have moles over liter, as we usually do. So you will have moles over liter, but also remember your volume needs to be converted from milliliters to liter, and you will be able to calculate the concentration of your sulfuric acid. So hope this helps you, and let me know in comments what else do you need for your lab to prepare you for lab. All right, I will see you in the next video. Bye.